Hello everybody, and already I have told you the linear property for Laplace transformation. Okay, and I have also done some problems, and today I am going to tell you the proof of fast shifting theorem and the application of fast shifting theorem and some more problems on our previous class. Okay, so it is very important. Already I have told you for B.Tech and B.Sc, and for net gate exams also it is very important. So, and it is also very important for physics and mathematics students, for both. Okay, so let us first prove the fast shifting theorem. Okay, so the fast shifting theorem it is very important. Fast shifting or translation fast shifting theorem or translation property or you may say S shifting. Okay, so what is the statement? If Laplace of f of t, small f of t, is equal to capital F of s, then Laplace of e to the power at t f of t is equal to f of s minus a, where s is greater than a. So this is the statement. If Laplace of f of t is equal to f of s, then Laplace of e to the power at t into f of t is equal to f of s minus a. That means s is converted to s minus a. So that is why you have written s shifting. Okay. To see the proof, given f of s is equal to Laplace of f of t. Clear? And what is Laplace of f of t? What is the definition? 0 to infinity e to the minus st into f of t, and you have to integrate with respect to t. Okay, so now what you have to prove? F of s minus a is equal to this one. So f of s minus a, very simple, and within 2 lines I will prove it, and in the exam it is a 5-mark question. Straight and prove fast shifting theorem for Laplace transformation. Okay. So in place of s I have written s minus a. In place of s I have written s minus a. So here also in place of s you have to write s minus a. Clear? So 0 to infinity e to the power minus s minus a into t into f of t, and you have to integrate with respect to t. So 0 to infinity e to the minus st into e to the minus 1 is plus e to the at t into f of t, and I am putting a bracket here, and you have to integrate with respect to t. And as I have already told you in my previous video, the function which is multiplied to these two terms, e to the minus st and dt, Laplace of that function. The function, again I am repeating, the function which is multiplied to e to the minus st and dt, so Laplace of that function you are writing. So here the function which is multiplied with these two terms is this function. So Laplace of this function. Is that clear? So is equal to Laplace of e to the power at t into f of t. So which is your LHS. Is that clear? Okay. That means what is your actually process? What you have to do while solving the problems? First of all, you have to find out this one. In the question, you should be given find out this one. That means the function which is multiplied with the exponential function. E to the power at t is the exponential function. The function which is multiplied with the exponential function, you should find out the Laplace of that function first. The function which is multiplied to the exponential function is f of t, and you should find out the Laplace of that function first. and let it be f of s. So while multiplying e to the power 80, simply replace s by s minus a. Okay. Now see here one corollary I am giving you. If Laplace of f of t is equal to f of s, then Laplace of e to the power minus t f of t. Here I have written e to the power t, but here I have written e to the power minus t. So the value will be equal to f of s plus a. Here s is greater than minus a. In place of a, I have written minus a. So here also in place of a, I have written minus a. That's it. Okay. So let us do derive some formulas first. And those formulas should be derived by using fast shifting theorem. Okay. So let us first prove the first formula. See here, Laplace of cos h big T, or the Laplace of cos h big T, or the formula s by, tell me, s square minus b square, s by s square minus b square, isn't it? Now, by fast shifting theorem, Laplace of e to the power 80 into cos hyperbolic big T. This is your f of s. And what is your fast shifting theorem? In place of s, you should write s minus a. In place of s, you should write s minus a. So here, in place of s, write s minus a, because the coefficient of t is a, not minus a. S minus a by s minus a whole square minus b square. So this is your first formula based on fast shifting theorem. And you should apply this formula directly to the problems. Okay. You should not do like this, and you should apply directly. Okay. Now, the second formula, Laplace of sin h big T. Your formula is b by s square minus b square. Now, by fast shifting theorem, Laplace of e to the power 80 into sin hyperbolic big T. As I have told you, in place of s, you should write s minus a. So b by s minus a whole square minus b square. So this is your second formula. Clear? So now, see here, Laplace of cos big T. The formula is s by s square plus b square. S square plus b square. So by fast shifting theorem, Laplace of e to the power 80 into cos big T, only you have to replace s by s minus a. So s minus a divided by s minus a whole square plus b square. So this is your third formula based on fast shifting theorem. Clear? Now, Laplace of sin big T. Here, b by s square plus b square. Clear? Now, by fast shifting theorem, Laplace of e to the power 80 into sin big T is equal to, only you have to replace s by s minus a. So b by s minus a whole square plus b square. So this is another formula. Clear? So these are the four important formulas which I have derived depending upon it or using first shifting theorem. Okay. So now let us see. But in the exam, if it will be 2 to 3 mark question, then do by process. Actually, this is a 1 mark question. Okay, so directly you should apply. But if they will give 3 to 4 mark question, then you should write 2 lines like this, as I have done it. Okay. So see here, one example. Laplace of e to the power 2t sin 3t. So this problem you should apply directly for 1 mark question. But if it will be 2 mark or 3 mark question, then you should do by process as I have done it. Okay. So, but I am doing directly. It is in the form of e to the power 80 into sin bt. E to the power 80 into sin bt. So say, recall, what is the formula for sin bt? It is b by b. Here b is 3. 3 by s minus 2 whole square. Trigonometry function, so plus sign should be there, plus b square. B square means 3 square, it is 9. So this is the answer. 3 by s minus 2 whole square plus 9. Another example, see here. Laplace of e to the minus 3t into cos hyperbolic 2t. See here, cos is there. So in the numerator it will be s. So in place of s you should write s minus a, but here a is minus 3. So s minus of minus 3. S minus of minus 3, that means s plus 3. In the numerator it will be s plus 3 divided by s plus 3 whole square, and hyperbolic function is there. So you should put a minus sign here, and then b square. B square means 2 square, it is 4. S plus 3, what is the original formula for cos hyperbolic? Bt. S by s square minus b square. S by s square minus b square. And using first shifting theorem, in place of s you should write s minus a. But here a is minus 3. So s plus 3 by s plus 3 whole square minus 4. So this is your answer. Clear? Now if the question will be like this, see here. Another question and another very important application I am going to tell you. Laplace of e to the power 2t into cos square 2t. Like this. The question will be like this. So it will be Laplace of e to the power 2t cos square theta. It is in the form of cos square theta, and cos square theta is 1 plus cos 2 theta by 2. So it is 1 plus cos 2 into 2t, it is 4t by 2. Cos square theta, the formula is cos square theta is 1 plus cos 2 theta by 2. But in place of theta, I have written 2t. So here 2 into 2t, it is 4t. So I have written 1 plus cos 4t by 2. Okay. So you should remember the trigonometry formula. Okay. So now take 1 by 2 outside by linearity property. So Laplace of e to the power 2t, put a bracket here, plus Laplace of e to the power 2t into cos 4t. Clear? So simply apply the formula directly. E to the power 80, 1 by s minus a. 1 by s minus a, here a is 2. Clear? Plus. So here e to the power 2t into cos 4t. Cos is there. So s minus 2. Because a is 2. Here also s minus 2 whole square. And now trigonometric function, so positive sign will be there. So 4 square, it is 16. So this is the answer. Clear? And keep like this. Don't simplify further. Okay. Now, see here another example. Laplace of cos 3t into sin 2t. How to find out the Laplace of this function? So there are four formulas: 2 sin A into cos B, 2 sin A into cos B, 2 cos A into sin B, 2 sin A into sin B, 2 cos A into cos B. Sin cos, cos sin, sin sin, cos cos. There are four formulas, and in each case there is 2 sin A into cos B, 2 cos A into sin B, 2 sin A into sin B, 2 cos A into cos B. Okay, so here cos A into cos B, but you should remember A should be taken as the larger angle. It will be better for you. One step will be reduced. Remember. Okay. So here this is A, this is B, because 3t is larger than 2t. Okay. So I am multiplying 2, dividing 2 and multiplying 2, so that it will become 2 cos A into sin B. 2 cos A into sin B. Okay. 2 cos 3t. While writing in the second step, you should write in a systematic way. That means larger angle should be written first and the smaller angle should be written second. Okay, so 1 by 2 Laplace of 2 cos A into sin B. 2 cos A into sin B, it is sin A plus B minus sin A minus B. Sin A plus B, A plus B, it is 5t minus sin A minus B, 3t minus 2t, it is t. So this is the formula, and 1 by 2 Laplace of sin 5t minus Laplace of sin t one by 2 sin AT A by a square plus a square 5 square 25 minus this is also sin t. That means here A is 1 by a square plus 1. So this is your answer. Clear? Now another question here. Laplace of sin 2t into sin 4t. So how to solve this one? It is in the form of sin A into sin B. So same way I am dividing 2 and multiplying 2. But as I have told you, you should write the larger angle first. So this should be written first into sin 2t. So 2 sin A into sin B, 2 sin A into sin B. It is cos A minus B minus cos A plus B. Clear? Cos A minus B, this minus this, 2t. Minus cos A plus B, this plus this, 60. You should remember the formulas. Okay. It is equal to 1 by 2 Laplace of cos 2t minus Laplace of cos 16. You should put the brackets systematically. The brackets should not be missed. Okay. You should not miss out the brackets. You should put the brackets in the proper place. So cos 80 s by a square plus a square, 2 square is 4, minus s by a square plus a square, here a is 6, so 36. So this is your answer. Okay, so you should write up to this one, don't simplify further. Okay, now another question is here. Laplace of sin 2t into cos square 2t. Like this, the question will be like this. Sin 2t into cos square 2t. Different types of problem I am solving, so that you should know how to apply the formulas. Sin 2t cos square t, it is 1 plus cos 2 into 2t, it is 4t divided by 2, put a bracket here and then put a curly bracket. Laplace of take 1 by 2 outside. Then multiply sin 2t into 1 plus, while multiplying I am writing the larger one first, cos 4t into sin 2t. Okay. And now separate it. Laplace of sine 2t, then plus Laplace of cos 4t into sine 2t. But here it is in the form of cos into sine b. So you should multiply 2 and divide 2 here. So put a bracket here. Clear? So 1 by 2 sine 2t, 2 by a square plus 2 square, it is 4. You should remember the formulas for Laplace transformation. Plus 1 by 2 is there. So Laplace of 2 cos into sine b. Sine a plus b minus sine a minus b. Sine a plus b, 40 plus 2t, it is 60. Minus sine a minus b. 40 minus 2t is 2t. It is equal to 1 by 2, 2 by a square plus 4 plus 1 by 2, it is Laplace of sine 60 minus Laplace of sine 2t. Clear? So 1 by 2, 2 by a square plus 4, then 1 by 2 sine 80, so 6 by a square plus 36 minus 1 by 2 is there, so I am writing 1 by 2 here, sine 80, again 2 by a square plus 4. So this is over. So now you can combine these two. This is a square plus 4, here it is also a square plus 4. So you have to combine and then write the answer. Okay. So you can do it. Now another question. Laplace of sine 2t into cos 2t. The question is like this. So it is simply divide 2 and multiply 2. Sine 2t into cos 2t. And this is 2 sine into cos a. 2 sine a into cos a, not b. 2t 2t. This is sine 2t, sine 2 theta, sine 2 theta, 2 into 2t. So sine 4t. So 1 by 2, this is 4 by a square plus 4 square, it is 16. Clear? Now, some different types of question I am going to solve. Laplace of sine hyperbolic 2t into cos 3t. Like this. If the question is like this, one function should be hyperbolic, another function should be trigonometry. So Laplace of sine hyperbolic converted to exponential form, e to the power 2t minus e to the minus 2t divided by 2 into cos 3t. Clear? So take 1 by 2 outside. Simply multiply e to the 2t into cos 3t minus e to the minus 2t into cos 3t. Clear? Then separate it. Laplace of e to the 2t into cos 3t, put a bracket here, minus Laplace of e to the minus 2t into cos 3t. So it will 1 by 2. This is in the form of e to the 80 into cos 3t. Today I have derived the formulas. So cos is there, so s minus 2, s minus a divided by s minus a whole square. Trigonometry function is there, so plus should be there, plus b square 3 square, it is 9. Clear? Please remember, otherwise it will become too difficult for you. This one, cos is there, so s minus 1 minus 2 s plus 2 divided by s plus 2 whole square plus cos is there, so plus 3 square it is 9. So this is your formula. This is your answer. Okay. So in this way you can do the problems. Clear? And in my next class I will tell you see here another question. One application of percepting theorem. Laplace of t to the 3 into e to the 2t. If the problem is like this, you have to find out this one. Okay. So, as I have told you, what is the Laplace of t to the n? It is, what is the formula? Factorial n by s to the power n plus 1. Is not it? Laplace of t to the power n, it is factorial n by, this is the answer or not? Yes, factorial n divided by s to the power n plus 1. So see here, as I have told you, the function, you should find out the Laplace of that function which is multiplied with the exponential term. You should first find out the Laplace transformation of the function which is multiplied with the exponential function. Here, t to the power 3 is multiplied with the exponential function. So, Laplace of t cube, you should first find out the Laplace of this one. Laplace of t cube means factorial 3 divided by s to the power 4. That means 6 by s to the power 4. Clear? So therefore, by fast shifting theorem, Laplace of t cube e to the power 2t. It will be simply in place of s you should write s minus a. Simply in place of s you should write s minus a. So here 6 by s minus 2. Here e to the power at, e to the power at, here a is 2. So s minus 2 whole to the power 4. So this is your answer. Clear? So another formula I am deriving. I am going to derive one more formula. Laplace of t to the power n is factorial n divided by s to the power n plus 1. Is not it? So therefore, by fast shifting theorem, Laplace of e to the power at t into t to the power n is factorial n divided by s minus a to the power n plus 1. So this is your formula. And you can apply this formula directly also for 1 mark question. For any competitive exams, for net gate or for easy entrance, you can apply this formula directly. Okay. So please remember the formulas for Laplace transformations, and as I have done in today's class, you should remember the formula for trigonometry. 2 sin A into cos B, 2 cos A into sin B, 2 sin A into sin B, 2 cos A into cos B, 2 cos A into cos B, 2 sin A into sin B. And again cos square theta, formula for cos square theta, sin square theta, and cos cube theta, sin cube theta, sin 2a, cos 2a, all these things. Okay, so simple formulas you should remember. If you remember this formula, then it will be very easy for you. Okay, and kindly read the formulas every day, only for 5 minutes, just for 5 minutes. Okay, simply for 5 minutes, not for 6 minutes. You should read for 5 minutes only. Okay, so if you are satisfied, fully satisfied, with my teaching, then please give a like button, press the like button. Simply one like. Okay. So thank you for today's class, and we'll see in my next video. Okay, and I hope you are enjoying this class. That means this Laplace transformation. So, and I am trying to satisfy fully. Okay, thank you. Bye bye.